What's going on, you guys? We're back for our 5th video in the Rapid Review AP Calculus series. In today's Rapid Review, I'm going to be going over applications of derivatives, so everything you need to know about this important applications of derivatives for the AP exam. I'm going to cover all of that in 10 minutes, so buckle your seatbelts and let's get right to it. A couple of things before we get started. Don't forget that in the bottom right-hand corner of the screen, or somewhere at least on the screen, I'm going to have the key concept related to the problem I'm solving so that you can go back and study specifically on that kind of concept if you're not sure about what I did really quickly, or go back and check my videos related to that concept. The other big thing I want to say before we get started is that I'm not going to actually cover all of the applications of derivatives because I created a separate video. There will not be related rates and optimization because I created a separate rapid review video on related rates and optimization. So that won't be in this video at all. Without further ado, if you want to check out that video, it's actually rapid review number 4, the one before this, go ahead and check it out. Otherwise, here we go, applications of derivatives. Let's go ahead and get started. Alright, here we go. We're asked to write the equation of a normal line to the graph of y equals e to the x at x equals 0. Before we get started, we should keep in mind that normal, for our intents and purposes, means perpendicular. So we're asked to find the equation of the perpendicular lines. When you want to find the slope for a perpendicular line, you have to take the reciprocal. So what we're going to do is we're going to do what we normally do. We're going to take the derivative of y equals e to the x, which is actually, you know, the nice thing about the derivative, like a phoenix rising from the ashes, the derivative of y equals e to the x is e to the x. So then what we do is we plug in 0 into the derivative function so that we get e to the 0. E to the 0 is 1, but remember that the slope of the normal line is the negative reciprocal of that slope. So we got to take the negative reciprocal of 1, and, well, 1's just 1, so the negative reciprocal is simply negative 1. We gotta find, now we have a slope, but do we have a point? Well, we have the x-coordinate, but we don't have the y-coordinate. Well, if we plug in 0, we find that we get that y is equal to 1, as we can see over here. We plug in 0 into our original function, which happens to be the same function, and we get that y equals 1. So the point is therefore 0, 1. We plug it into our awesome point-slope form equation. We get this equation. If this doesn't make sense, check out the equations of tangent lines and the equations of normal lines, and then you'll be able to get this problem. But a pretty simple application is just writing the equation of tangent lines. Find the linear approximation of f of x equals x cubed at x equals 1 and use the equation to find f of 1.1. Well, here's the nice little secret little trick to linear approximations. If those get confusing, if the big word linear approximation confuses you, well, here's what we're going to do. All we're going to do is we're going to find the tangent line at x equals 1 and then plug in the value of 1.1. Because, guys, here's the thing. Really, really, really close to x equals 1, that tangent line is going to be roughly equal to the function at very, very little small intervals around it. Well, 1.1 is a very small interval around 1. It's only 0.1 away. So if we find the equation of the tangent line, then plug in 1.1, we'll get a good approximation of what x cubed is, or what f of 1.1 specifically is. So, therefore, I'm going to simply find the equation of the tangent line. How do you find the equation of the tangent line? Guys, it's pretty simple. We just did it. You take the derivative of x cubed. Guys, it's easy. 3x squared. You guys can do that in your sleep now. Remember, we got to plug in 1. We're finding it at x equals 1. Plug in 1, you get 1 squared times 3. It's 3. Boom, you got the slope. You need a point, first of all. We do need to pull that point out. Well, we know that x equals 1. I plugged that into the original equation. 1 cubed is simply 1. The point 1, 1. Boom. Put the point 1, 1 into point slope form. We did that right here. Simplify it out. You get y equals 3x minus 2. But we're not done. We're not asked to find the equation of the tangent line. We're asked to find the linear approximation and find f of 1.1. So what do we got to do? We got to plug in 1.1. We go over here. We plug in 1.1. Easy calculations. It's about 1.3. Boom. Don't make linear approximations more complicated than they should be. You're finding the equation of the tangent line and plugging in the value they tell you. If you want more help, check out my video on linear approximations. Guys, I cannot stress this enough. I can guarantee you that there is going to be an FRQ on motion. So you really got to know your motion. So here we go. A whole problem dedicated to motion. 2 parts. We got to find when the acceleration is 0. And we got to find the intervals where the particle is speeding up and slowing down. So let's jump right into the problem. we should note that this graph we're given is velocity. So we happen to know the velocity. That's all we happen to know. We have to figure out everything else based on the context of velocity. Well, we know that acceleration is the derivative of velocity. Because acceleration is the derivative of velocity, and we want to find when the acceleration is equal to 0, we simply have to find the point on the tangent line where it's equal to 0. We happen to find that this is the point where the tangent line is equal to 0, or the tangent line has a slope that is equal to 0. Happens to be right here at 2. Therefore, the acceleration is 0 at time t equals 2. Let's move on to part B. We got to find the intervals where the particle is speeding up and slowing down. Now, this is a huge error many students make. Many students are going to tell you that speeding up and slowing down is only based off of velocity, but that is actually not true. In order to do a speeding up, slowing down problem, you're going to need both velocity and acceleration. If you don't use both, I can guarantee you are not going to get full credit. Make sure that you use both velocity and acceleration. So let's take a look here. Remember, if velocity and acceleration are the same sign, it's speeding up. If they are opposite signs, you're slowing down. So let's take a look. On the interval from 0 to 2, it seems like acceleration and velocity happen to have the same sign because, well, velocity is positive on this whole interval, as you can tell, because velocity is always above the x-axis. So velocity is always positive, and we find that if we draw multiple tangent lines, I'll even do it for you guys. Oops. Let me redo this. Make that go away. You're wasting my time. Okay, here we go. If we look here, we draw a tangent line here. We draw a tangent line here. These are not beautiful tangent lines. We can tell that they all are positive tangent lines. They're the same sign on the closed interval from 0 to open interval 2. You're speeding up. Let's take a look at 2 to 4. What's happening here? Well, now I can go ahead and draw. Let me do it. I am going ahead and drawing. Velocity is still positive. It's still above the x-axis. So velocity is still positive, but I'm drawing a bunch of negative tangent lines. Therefore, the slope is negative. Acceleration is negative. It's the opposite of velocity, which is positive. Therefore, you're slowing down on the interval from 2 to 4. Motion, 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 motion. You guys, get your motion problems down. I say motion is so important that I made another problem on motion. So let's do this other problem on motion. We're asked to find the maximum acceleration of the particle. It's got a velocity given by this function. So we need to find the maximum acceleration. Now we're going to have to tie it into some other stuff we did on the graphs of derivatives. We're going to have to find maxes and mins. So how do we find maxes and mins? Well, first off, we need to find the acceleration. We have to know that the acceleration is the derivative of velocity. Dude, plug and chug, guys. The constant's going to go bye-bye, and the derivative of t squared is 2t. Guys, pretty simple. Like back of your hand, in your sleep kind of stuff. That was not the hard part. Okay, we happen to know that acceleration is linear and has a positive slope. How do I know it's linear? Well, it's in the form of a linear equation. It's in the form of mx plus b. It's just that b happens to be 0. And how do I know it has a positive slope? Because this number right here, this constant that's being multiplied by the independent variable is positive, and that is the slope right here. This 2 is the m. It's positive. It has a positive linear function. Therefore, the maximum has to occur at the endpoint. We don't have to do any fancy calculus. We just have to know. It's just obvious, guys. Linear equations. I mean, we know that this graph is going to look a little something like that. So, if we're looking for a maximum on 2 points on the interval, well, obviously, the maximum point is going to happen at the end point. I mean, it's pretty simple, you guys. So, that since the max has to occur at the end point, we're looking on the interval from 0 to 4. 4 is the right end point. If we plug in 4 to this equation, we get 8. Therefore, the maximum acceleration is 8. Again, guys, review your motion problems. It's so crucial. Thank you guys so much for watching my video. We're finally done. You made it through the 10 minutes. I want you guys to know before you click, you can click the end of the video and just click away. If you can click X and not see this again, but I want you guys to hear this. So please do not. I want you guys to hear that you are more than a test score. Even if you don't pass, I really hope you pass. I really hope you get a 5. That's why I'm making all these videos. But I want you to know that no matter what happens, you're going to get this score. It's got a finite end. Life is infinite. Life's going to keep going on, you guys. and this test score is going to mean nothing. You are so intelligent, you are so talented, and you're going to go on to do some incredible things in life. So don't let this AP test score shut you down, but rather go on, move further, eat some sugar, eat some junk food, do the things you like to do. Enjoy life, please. I ask you. Don't just waste your life on this one AP test score thinking it's going to mean the world to you and define who you are. It's not. Enjoy life. Enjoy the finer things in life. But before you enjoy life, you gotta, you gotta subscribe and like the video, because then that shows that you actually care about what I'm making and that I make good stuff. And that helps me out, because it helps me know that you guys like the stuff I make and that I should keep making this stuff. So definitely please like the video and subscribe and all that jazz. And I really appreciate it. And now you can go and enjoy life. Thank you guys so much for watching. I'll see you guys in the next Rapid Review video.